Now just we'll go through this. The kernel is responsible for routing the IO request, right? Say for example, my process may read some data from the peripheral, or it needs to write some data into the peripheral, right? So in that case, there should be a driver that is compatible to this system along with the corresponding peripheral, right? So that is actually provided by this operating system. And the kernel should maintain the list of all IO devices connected at any time into the system. That needs to be done. And then the service device manager of the kernel is responsible for handling all IO related to IO related operations. And the kernel talks to the IO device through a set of low-level system calls which are implemented in the system service called device drivers. Right? I think you should be knowing, right? Whenever you install a printer, you have to install the printer driver, so that it will understand in which format the data need to be sent to the printer, right? And then the device manager is responsible for loading and unloading of device drivers and the exchanging of information and the system specific control signals to and from the device. I think this device manager is available in almost all Windows systems, right? You can just go through the device manager, especially the hardware device manager, where you can easily see what are all the devices, how many ports, how many processors, how many monitors, everything is connected to the system, right? So that is available in the device manager. The next thing is a secondary storage management. So here we are going to deal about the hard disk, right? Especially, or it can be a non-volatile memory file. So this secondary storage is used as a backup medium for the programs and the data, right? Normally we do this using a hard disk. And the disk storage allocation, disk scheduling, especially the backupping of data, right? I mean, periodically you have to back up your data, right? So all these things need to be done. And free disk space management. Say already there may be some junk files which need to be deleted, right? So the secondary storage management needs to be done. And the protection of the systems, again, as I said, whenever you are using a Windows system, you will be having administrator rights or standard rights or restricted or guest access. So there will be some levels of protection available for the files that are available inside the computer. So that need to be done in the protection of the system. Especially this is needed in the case of multi-user supported operating systems like Windows and all those things, right? And in addition, some application may not granted with permission to make use of some of the system resources, especially whenever you are inserting a pen drive with the virus, right? So your system may be corrupted. So in that case, normally the system owner, what they can do is he could have done disabled the USB pen drive access, so that even if you insert the pen drive, that will not get access, right? So the permission needs to be granted to each and every device or to each and every system resource. So that comes under this protection of the systems. And interrupts. Supposing if there are any interrupts, then how my system should respond for that, right? Especially there is a power supply fluctuation, again it's a sort of interrupt, or if there is a low voltage, right? So my SMPS switches off. So how my system should respond for all those hardware and software interrupts, that need to be done. And then the next thing is the kernel space and the user space. Normally actually we have two spaces in the memory we can call. One is actually the kernel space where the user applications will be stored. And the other, the first thing is actually the user applications, and the second thing is actually the kernel applications, right? The user applications, what the user is actually writing, and the kernel applications are the program that is executed by the operating system as a services. And the kernel space is the memory space at which the kernel code is located, right? So usually the code that belongs to the operating system, right, that will be there, that is actually called as a kernel space. The kernel applications or services are kept in this contiguous memory of primary memory, and it is protected from unauthorized access, because we should not be able to alter the OS code, right? So that will be normally a read-only memory, we can say. And the user space is actually the memory area where the user applications are loaded and executed, right? So what we write in our program, that is there in the user space. And the partitioning of memory into kernel and user space is purely OS dependent, right? So the OS will take care of which part of memory should be used for user and which part of memory should be used for the system kernel. And some OS implement this kind of partitioning and protection, whereas some OS do not segregate the kernel and user aggregation. So sometimes it can segregate the two or differentiate the two, and some uses both the things in the same memory area. and the monolithic kernel and the microkernel. So there are two variations that are available in the monolithic kernel and the microkernel. So already we discussed the kernel is the heart of the operating system. And different approaches are adopted for building an operating system kernel. So there are two types, of course, we said, it's a monolithic and a microkernel. So in the case of monolithic kernel, all kernel services will be running in the kernel space. Of course, that we know that, right? So all the kernel services or the kernel programs will be running in the kernel space. Here, all kernel modules run within the same memory space under the single kernel thread. So the tight internal integration of kernel modules in monolithic kernel architecture allows the effective utilization of low-level features of the underlying system. So whenever we write a program for kernel access, right? So that is actually the part of OS, we can say. So whatever the low-level features available, say for example, especially you can make use of the registers that is available, right? So that is actually the lowest level that is available inside a microprocessor or microcontroller. So the effective utilization of the low-level features of the underlying systems can be used if we write the program for your monolithic kernel, right? And the major drawback of the monolithic kernel is, suppose if there is any error or failure in the one of the kernel modules, then the total system will get crashed. And some examples for this monolithic kernel is Linux, Solaris or MS-DOS. This is actually the maybe a structure that the monolithic kernel has. So you can see on the top side you can have the applications, right? So the whatever the user writes, so those programs will be there on the top. And in the bottom you are going to see the complete set. So what are the things available? There is an operating system is available, and all the services will be available that takes care of the kernel space, right? So everything is available in a single space. So the main advantage is it is easy to use, of course, right? Everything is available in the same location. But the problem is, suppose if some system fails, some service fails, then the total system will be failing. The other option is actually the microkernel. I think if you see the diagram, you can easily understand here. So here we are going to divide the kernel essential services and non-essential services are two variations, right? So here actually what we are doing is the microkernel with the essential services like memory management, process management, timer will be available in the kernel. And those services which are not very critical will be stored in the user space, right? So it will not be stored in the kernel space, so it will be in the user space. Suppose if there is any problem in the printer, right? I think there is a printer service available, right? That you will be calling it as a printer spooler. I think you can see this word in your laptop or Windows systems. So whenever there is some problem in the printer, your system will work, of course, because it is only a service. So only you can't print the data, but your system will work. But suppose if you use a monolithic kernel, so in that case, even if the printer fails, then you cannot use the total system. So I think now you can differentiate what is actually the monolithic kernel and the microkernel. So again, let me repeat, in the microkernel, only the essential system services will be available in the RAM or in the kernel space, and the other auxiliary services, right, or non-priority oriented services will be available in some part of user space along with the applications. So here the microkernel based design approaches, what are the following, what are the benefits, right? So the first thing is robustness. So here actually if there is some problem with the services which runs as a server application, the same can be reconfigured and restated, right? Suppose if there is a problem with the printer, that service alone can be stopped and again it can be rerun. So in that case, your original OS or the kernel operations will not get disturbed because of that. And thus this approach is highly useful for systems which demands high availability. So all the time my system will be active. And since the services which run as servers are running on different memory space, the chances of corruption of kernel services are ideally zero. Right, so the printer driver or the printer function will not disturb the original operating system function because both are running in the two different memories, right? And the configurability, any service which runs as a server application can be changed without need of the complete restarting of the system. So if I want to change the printer driver, I need not disturb my complete OS. Right, so only that process need to be stopped and immediately I can reconfigure that thing, right? So that is again the configurability is possible, especially the dynamic configuration is possible.